up until now, we've been finding the length of the sides. From now, we're going to be finding this theta angle itself. So previously, using Pythagoras' theorem, if we had two of the sides, we could always find the third side of a right angle triangle. So if we had that one and that one, we could then find that. Then we found that if we have one of the sides and the theta angle, we could find either of these two sides by exploiting these formula up here. What though if we wanted to find the theta angle itself? How might we do that? Well, it's now an algebra problem. So we want to make theta the subject of this equation. So say we've got the opposite, and the opposite is 10, and the hypotenuse is 15, and we're not interested in finding the adjacent, we're interested in finding the theta angle. What do we do? Well, if we remember that 1 over x is equal to x minus 1, we can kind of use that to solve this. Could we just divide both sides by sine? The answer is no, we can't, because sine is not a thing, it's an operator. It's like an instruction to do something to that, so it makes no sense. But the way it's written, the way it's set out on your calculator, is kind of the same terminology. It looks kind of similar. That's why I bring it up. We can bring the sine over, so that the theta, if we solve it for sine, for theta, is going to be sine -1. Inverse sine is the opposite over the hypotenuse. So these opposite hypotenuse, adjacent, hypotenuse, and opposite, adjacent, those ratios still hold. And the reason I write that in that form is that this is probably the form that your calculator will be set out as. So if you look here, the sine, cos, and the tan buttons, above it will be sine -1, cos -1, tan -1. The inverse functions. And the way we would find on these Casio calculators is we would go shift sine -1. And just a reminder that you always make sure that you're in degree mode. Okay, well, let's find this one then. So we're told that the opposite is 10, the hypotenuse is 15. We're going to use sine. So theta is going to be equal to sine -1, 10 divided by 15. So let's put it in. Sine -1. Now in these Casio calculators, I would recommend that you put a bracket in there. These Casio calculators can be quite fickle. We don't want to find sine -1 of 10 and then divide everything by 15. It wouldn't be the same. Set up there 41.8 degrees. And how would we find the other angle? Well, the other angle, remember, all the angles in a triangle are 180 degrees, including right angles. So it's going to be 180 minus 90 for the right angle, minus 41.8. -180 minus 90 minus 41.8 to one decimal place, 48.2 degrees. And that's that. As always, the best thing to do is just a whole bunch of examples. Let's say that we've got the... Let's say the adjacent side is 12 kilometers and the hypotenuse side is 20 kilometers. Again, the kilometers are going to cancel. So what are we going to use? Well, we've got adjacent and we've got the hypotenuse, and we want to find the theta. So which of these has adjacent and hypotenuse? Well, it's going to be cosine. So we're going to use cosine. So we know that cosine theta is adjacent over hypotenuse, so therefore theta must be cosine inverse adjacent over hypotenuse, which is cosine -1, and the adjacent side is 12, the hypotenuse is 20. Grab your calculator, find the answer. So shift cosine -1, I always go brackets. I know you can simplify this as 6 over 10, 3 over 5, but let's just go pick up a brackets. 12 over 20, 53.13 degrees. 2 decimal places from now on, let's say. 0.13 degrees. Degrees is the unit, not kilometers or anything like that. If these are the same units, kilometers over kilometers, we're fine. If this was centimeters and this was meters, then we would need to put them into the same units scale, but that's our answer. This time, let's say that the opposite side is 9 centimeters. The adjacent side is 10 centimeters. Obviously, this isn't to scale. Which one are we going to use? Well, what have we got? Well, we've got the opposite side. We've got the adjacent side. What are we looking for? We're looking for theta. So we've got that, we've got that. So of these three, sine, cos, or tan, which one are we going to use? Which one has opposite and adjacent? It's going to be tan. So therefore our theta is going to be tan inverse opposite over adjacent. So the opposite is 9, the adjacent is 10. Grab your calculator and let's work it out. Tan -1 brackets 9 divided by 10, it's 0.9, but put it in 41.99 degrees. Alright, for this one, let's say that this is 3 centimeters, this is 4 centimeters, and this is 5 centimeters. This is the famous 3, 4, 5 right angle triangle. How big is theta, and how big is this other angle? Let's call it Bob. Alright, so in this case we've got opposite, we've got the adjacent, we've got the hypotenuse, and we're looking for theta and Bob. Okay, which one are we going to use? Well, we could use any of them. Let's choose adjacent and hypotenuse. So theta is going to be adjacent to hypotenuse is going to be cosine, so it's going to be cosine -1. Adjacent is 3/5. And we grab our calculator. Cosine -1, 3 divided by 5, 53.13. Degrees, 2 decimal places. Alright, let's work it out using tan. Say we're told to work it out using tan. Well, tan has opposite and adjacent. So theta is going to be tan -1. Opposite is 4. Adjacent is 3. And when we put that in our calculator, so I'm just getting WhatsApp messages. Tan -1. 4 divided by 3 is 53.13, and if you look there you can see it's the same number. Kind of shouldn't be much of a surprise. There can only be one theta. Okay, now let's work out Bob. Well, a couple of ways we could do Bob. We could make Bob the theta, so that now the adjacent becomes the opposite becomes the adjacent, but we know that all of the angles in a triangle add up to 180 degrees. So Bob is going to be equal to 180 degrees minus 90 degrees, which is the right angle, minus 53.13. And again, I'm going to need the calculator. 180 minus 90 minus 53.13. 36.87. degrees. And that's that.